Okay, so now we're going to have a look at the typical acid reactions. So you should have your practical sheet ready, and then we will have a look at the observations and fill in the sheet as we go. So our first reaction is going to be the piece of magnesium ribbon reacting with our ethanoic acid. So if we pour the acid in to start with, so we can see, just like all the acids we've used, we've just got a colourless solution there. Now we'll pop a piece of magnesium in. There we go. Now maybe I'll bring this closer to the camera, that might be easier. So hopefully you can see there that it is fizzing away like crazy. So our first observation can be obviously the effervescence. Remember, if you're looking for more than one observation, don't write effervescence and fizzing, because you might as well have just written one of them down twice. It means the same thing. So we've got that fizzing away there. Alright, so what's going to be happening to the piece of metal? So we can go back and have a look at the end, but we're going to expect that piece of metal to react away. So that's another good observation. So the silver metal reacts away with effervescence, and then we can have a look at the nature of the solution at the end. So thinking back to your typical acid reactions, acid plus metal gives us what and what? So hopefully you've remembered salt and hydrogen, so we can test to confirm that. So we need to have our lit splint. So I'm going to put my thumb over the top of here to collect the, stop the gas escaping for a minute. My able assistant is lighting a match and lighting our homemade splint. Okay, and then we'll keep our fingers crossed that we manage to get a bit of a pop for you. Okay, so sometimes we put the spare test tube over the top, but that wasn't working particularly well. So we just went for the thumb. So normally use a spare test tube, but putting your thumb over the top works quite well as well. Right, we're just getting the splint lit. You can probably hear that match going on in the background. There we go, so that's burning nicely. So I'm coming in with my splint, so listen carefully. Whoa, that was a good one. That was better than our trial one. Okay, so a nice convincing pop that we have got hydrogen there. So we can then think about our overall equation. Okay, so if we just borrow the board over here. So if we have started off with ethanoic acid, so we write that down, CH3COOH. Now the acidic H is this one at the end, so that is the one that's going to be replaced with our metal. So we've reacted it with magnesium, and we're going to produce magnesium ethanoate. The charge on the ethanoate ion is going to be 1- because we're just losing 1 positive, and magnesium ions will be 2+. So we're going to need 2 lots of the ethanoate ion, and then, as I was saying, we put the magnesium in the place where the hydrogen was in the first place, and then our squeaky pop convincingly showed us that we had hydrogen there. So in order to balance our equation, we have got MgMg, but we've got 2 ethanoates, so we need to make sure we've got 2 ethanoic acids over the left, and then we've got our hydrogen there. Okay, so that's the reaction with magnesium ribbon. Now, the second reaction on your sheet is the one with the little sodium carbonates. Now, if you go and find some vinegar at home and find some bicarbonate of soda, then you can carry out that one yourself. So I will demonstrate it, but I'm going to do that one last, so that gives you time to pause the video and come back later and do that one. Now, actually, just in the meantime, let's just revisit that magnesium ribbon. So although it's kind of looking cloudy just because of a huge amount of effervescence that's going on, right down the bottom you can see we've got a colourless solution as well. So we can add to those observations that our solid reacts away or disappears, we have effervescence, and we form a colourless solution. Okay, so we'll have a look at C next. And this one, we are going to be reacting a little copper oxide with our ethanoic acid. So we've got our test tube here. We're going to put some ethanoic acid in, and then this time we're just going to react a small amount of copper oxide there. Okay, so if we put the copper oxide in, so copper oxide's a black powder. So already we can be saying a black powder reacts with a colourless solution. Now, it says we can heat over a Bunsen burner. We don't have a Bunsen burner here, unsurprisingly. And so we're going to use our little spirit burner that we used for our other lesson there. And then we can still heat it. It does end up getting a little bit sooty, but we can live with that and wipe that off. Okay, so can we light the spirit burner? Awkward matches. Go on. Yay! Right. Okay, so spirit burner's lit, and then if we hold the test tube into the flame there, and then we're going to warm that. So again, we can be thinking about what we expect to happen here. So we've got an acid reacting with a metal oxide. So acid plus metal oxide gives us, and we should be having to think about what our two different products are going to be there. Okay, so hopefully there you've come up with salt and water. So we had our ethanoic acid and our copper oxide. So what do we suppose the salt is going to be here? Okay, so like our previous one gave us magnesium ethanoate, this one should give us copper ethanoate. So we're heating it here. The black powder, some of it is staying there, so we don't need to heat it for too long. So if we put that into the test tube rack, some of the black powder is still staying there because we don't need very much to react with our ethanoic acid. Just blow the flame out now. Big puff. There we go. And we will leave that to stand for a few minutes and then come and have a look at what we can see. You do need to be careful with observations like this and think, did you put something in the first place, and is it just still present, as opposed to the solid formed when you react two solutions together, which is going to then be a precipitate. So in this case, any black stuff you can see is just unreacted copper oxide that hasn't gone. So start of our observations could be that a black solid reacts with a colourless solution, because that's what we had to start with. And then I think now you should start to be able to see, yeah, look at that. Okay, so we've got a really nice blue solution being formed here. So the black that we can see at the top and possibly a little bit at the bottom there as well, that's just unreacted copper oxide. If I put in a load more ethanoic acid, that would go. But the blue solution in the middle is what's actually the product of the reaction. And that shouldn't be surprising. We've said it's going to be copper ethanoate. We're used to copper compounds being blue, like a copper sulfate, and so that is what we have there. So we can also then think about the reaction and the overall equation. So let me get my board out again. Okay, so this time we had our ethanoic acid and we reacted it with copper oxide. Remember, Cu2 plus and O2 minus, so copper oxide is just CuO. And again, we're going to form our salt, so it's the acidic H at the end that is going to be involved in the reaction. The ethanoate ion, 1 minus, copper is 2 plus, so we need 2 lots of the ethanoate ion to counterbalance the charge on the copper. So our copper ethanoate looks like that. We use we've got 2 ethanoate ions there, so we must need 2 ethanoic acids here. And then that leaves us with 2 H's and 1 O. So that makes us our H2O on the end. So there we go with so you can see it, with the balanced equation for that one. And those observations, so colourless solution reacts with a black solid to form a blue solution. Okay, for experiment D, we are going to look at how universal indicator changes when we add sodium hydroxide drop by drop. So I'm going to put the colour chart in front so that we can see that. And let's bend the tripod down a little bit, slightly wonky, but we'll have to live with that. Okay, so I've got my ethanoic acid in here, so we're going to put 2 drops of universal indicator in. 1, 2. There we go. So not surprisingly, that's a nice red colour, so it's got a low pH, somewhere between 3 and 1. So remember that this is a weak acid, so it doesn't fully dissociate, so it's not going to have such a high hydrogen ion concentration in comparison with the same acid concentration of HCl, for example. So we're going to put sodium hydroxide in drop by drop, maybe a few drops by a few drops, and we're just going to keep an eye on what's happening to the pH. Okay, so if we watch these going in, so we're up to about an orangey colour already. Can we see that one there? Whoops, sorry, I'm moving it away from the dropper. Okay, so if we just pause for a minute. So now we've been through orange, now we're up to about a pH 5, so we're reacting away our acid there. So a little bit more, stop, there we go. Okay, so you might have been able to see that green colour, and now we're through the green colour, meant that we'd completely neutralised the ethanoic acid, and now we've reacted away all of that ethanoic acid, and any extra sodium hydroxide is just going to make the solution alkaline. So when we've got ethanoic acid and sodium hydroxide reacting, we've got acid plus alkali giving us, and hopefully you're all saying salt and water there. So for the equation for that one, we can write our ethanoic acid plus sodium hydroxide gives us, so the ethanoate ion 1 minus, the sodium ion 1 plus, so sodium ethanoate plus water. I'll move this back in a sec so you can see all of that. Sodium ethanoate plus water. Now, in terms of the observations without an indicator present, you just see 2 colourless solutions reacting to form a colourless solution. You might notice a temperature change because it is actually an exothermic reaction, but other than that, there's nothing to observe. Once we put the indicator in though, we see the colour starting from red, going through the orange to the yellow and green briefly before we added excess sodium hydroxide, and then we just see the colour of the excess sodium hydroxide. At the neutral point though, at the point where it was green, all that we had present was just our sodium ethanoate and our water. It was just once we were adding excess sodium hydroxide, there was no more acid for it to react with, and so that left the solution as being alkaline. Then if you are planning to go and do the kitchen chemistry, then this is the time to pause the video. Okay, so disappear to do your kitchen chemistry. If you've stayed, then we'll show you what happens. So if you didn't have the right chemicals, then that's absolutely fine. So I've used a bit more of the ethanoic acid that we had from school, but you might have vinegar here. So we've got our ethanoic acid, a coloured solution. If you used normal vinegar, it would be a brownie colour. You might have distilled vinegar, in which case it would be colourless as well. And we have our bicarbonate of soda, which is basically sodium carbonate. And my helper here has a ton of the stuff on a teaspoon because it's kitchen chemistry now. So we're going to chuck that in. Whoa. Okay, so we'll see if this goes straight over and actually does a volcano on my kitchen table. Okay, no, it was just enough to go back down again. So we can see masses of effervescence going on there. Okay, so hopefully you've had fun if you did that in your kitchen yourselves. So this one, we've got ethanoic acid reacting with sodium carbonate. So our colourless solution reacted with our white solid. And if I give it a bit of a swirl, I think it is all going to react away there. So we can certainly say that the white solid disappears, or most of the white solid disappears if we've added excess, and it reacts to form a coloured solution. So it's looking a little bit cloudy at the moment, but once the excess particles settle to the bottom, we will see definitely a colourless solution there. So likewise with the other ones, we can go back to our equations. Oh, and of course we need the effervescence for that observation as well. I missed that one. So a colourless solution with effervescence. So with our little, or not so little, sodium carbonate, we can have our ethanoic acid, whoops, getting a bit wonky here, reacting with our sodium carbonate, so sodium 1 plus, carbonate ions 2 minus, so we need 2 of the sodiums to counterbalance the charge. And just like before, the acidic H is the one that's removed, and the sodium takes its place, 1 plus or minus, so it's a nice simple one like that, plus the carbon dioxide from all that effervescence, plus water. Then to go back and balance it, we had 2 NAs in the sodium carbonate, so a big 2 for the sodium ethanoate, 2 ethanoate ions there, so a big 2 in front of our ethanoic acid. And then if we check through, everything else should be fine. So 1C, 1C, 3 O's, 1, 2, 3 O's there, 2 H's that we hadn't used there, and 2 H's there. Okay, that's the end of your reactions of ethanoic acid.